Assalamualaikum, I'm Umar Farooq, ID 12008043, Department of CC, Kuala University. Today I am present on Convolutional Neural Network. Before I start my presentation, we have to know what was wrong with DNA. For fashion dataset, we flattened the 28 by 28 image into a 780 pixel vector. Spatial relationships was destroyed because the model has no idea that pixel 00 is next to pixel 01. The network has relearned spatial pattern from scratch. This problem is solved by our CNN because instead of connecting every pixel to neuron, look at a small region at a time. Learn detector, slide this detector. So without further delay, let's start my presentation. First, we will define what is CNN. Actually, CNN is a type of deep learning networks architecture that is partially well suited to image classification and object recognition tasks. It transforms an image into a feature map, which is then processed through multiple convolution and polling layers to produce an predicted outputs. Now we'll see layers of convolutional neural networks. Convolutional layers, polling layers, activation layers, fully connected layers, normalized layers, dropout layers, dense layers. Now we'll describe convolutional layers. Convolutional layers responsible for extract features from the input image. It performs a convolution operation on the input image where a filter kernel is applied to the image to identify and extract specific features. In the pictures, we see that an kernel is applied for, to an input image and abstract features through the layer. Now we'll see polling layer that is responsible for reducing the spatial dimension of the feature maps produced by the convolutional layers. It also performs a downsampling operation to reduce the size of the features maps and reduce convolutional complexity. Actually, polling layer has two types: max polling and average polling. It divided the input vectors or pixel into four sections. In max polling, it takes max pixel, and in average polling, it takes average pixel. Now we'll see activation layer. Applies a nonlinear activation function such as the ReLU function to the output of the polling layers. It helps to introduce nonlinearity. Well, now we'll see fully connected layer connects all the neurons in the previous layer to all the neurons in the next layers, responsible for combining the features run by the convolutional and polling layers to make predictions. In the normalized layers, the base normalization or layer normalization to ensure that the activation of the layer are well conditions and overfittings. In the dropout layers, it is used to prevent overfitting by random dropout neurons during training and ensure that the model has not memorized the training data. In the dense layer, the convolution and polling layers have extract features from the input image. The dense layer can then be used to combine those features and make a final predictions. The overall overview is here. It take an input and pass through the convolutional layers, then extract features, then it pass through the polling layer, that is summarization layers. It reduce the size of the and the abstract the more features. Then it passed through the flattened layers that convert the 2D image to 1D image, and then it connected to fully connected layer that's connect previous layer to next layers, and finally we take an input. Now we'll see working of convolutional neural network. The above architecture is implemented here by a visual image. Here the input image, which is zebra. In this image, we applied filter to abstract features, and in the polling layers, we summarize the features and that reduce the size and abstract the more complex features. And the flattened layers on the each converted 2D vector to 1D vectors. And fully connected layer, it takes the previous neurons to the next neurons, and finally it predicts the outputs. Now we'll see some applications of convolutional neural networks. image classification, object detections, semantic segmentations, style transfers. Thank you all for hearing me.